I'm going to talk about why it's kind of similar. Why I think the Kotlin DSL, the Gradle Kotlin DSL, is cooler than Groovy. First, a little about me. I'm an Android enthusiast, kind of a big Google nerd in general. I am an organizer of a Google developer group, a GDG Silicon Beach here that serves the cities on the west side of Los Angeles County. And I'm a lead Android appetizer, as we call ourselves at Appetize, focused on developer productivity and release engineering. A little bit about Appetize. So Appetize provides enterprise cloud point of sale and digital ordering platforms for high volume business. So theme parks, music festivals, sports stadiums, all the things that are currently closed, unless you're in Florida. It's really love working there. It's a great crew of people, very dedicated. It's pretty awesome. And there's one thing about Appetize that's sort of great is that it's in between. It's grown really quickly, and so it's sort of in between being a startup and a large enterprise, so it still has that startup feel, but they're making big waves. Groovy Gradle. So Groovy is the first language of Gradle, which is a build automation tool. It's very popular and gaining popularity for its versatility, but it's also the official tool for Android development. Its syntax is very Java-like, which is nice, and because it's a superset of Java, Java programs will run in Groovy environments, though vice versa, maybe not so much, or certainly not consistently. And so Groovy is gravy. It's actually a pretty great language. I'm not here to disparage Groovy at all. It has a lot of great features. Its getters and setters are automatically generated for class members. It is compiled to the JVM bytecode. Sounds familiar when it comes to Kotlin. And so, compatible with the Java platform. And it is both a scripting language and a programming language. So basically, it's a scripting language that writes like a programming language, which is also really nice. And then it's super easy to type. Like, it is agnostic about virtually all punctuation, operators, all these kinds of things. So it actually ends up saving a lot of typing, certainly in comparison to Java. However, problem is that Groovy gets gradled, which in an Android environment especially is a pain to debug. It's partly Gradle's fault, partly the IDE, but getting readable feedback can be a heavy lift. It's possible, but it takes some sort of extra configuration that certainly doesn't come in the box. And you probably saw in Sam's presentation how much help the IDE can be, especially in IntelliJ IDEA, and by extension Android Studio, which is basically the same IDE, just tooled for Android. And so the one aspect of our Android applications that doesn't benefit from these things are our build scripts. So we don't, there's no compile time checking in a Groovy build script. There no code completion, or at least no code completion for any custom classes or variables. And refactoring is just non-existent. And so Kotlin comes fourth. It became basically the fourth language, optional or otherwise, to be used in Android development environments alongside C, C++, obviously Java, and then by association with Gradle, Groovy. And of course, there's nothing inherently wrong with having all of these languages involved in Android development, but as projects get more complex and teams get bigger, this can become problematic in terms of developer productivity, where as the teams grow, seconds start to become very important across time budgets and monetary budgets in terms of cost of developer time. So one lang to rule them all. A lot of Android projects are now using Kotlin only. Sam gave some great stats on how adoption of Kotlin in the Android world has grown incredibly rapidly, really. But I think most Android engineers and projects are probably still in the process of phasing out some of their Java code if they're not a brand new app. So they've got this sort of mixture of legacy Java code, new Kotlin code. That is, again, one of the brilliant things about Kotlin is that we don't have to throw out all the Java. We can build on top of our current Java-based code base and not have to worry about refactoring everything. And then we're using Groovy in our build scripts, which again is really close to Java, but it's another language to deal with. And as we see Kotlin grow, as again, as Sam said, Kotlin isn't just for Android, it is cross-platform. I know of at least one prominent company, I think it's Bird, if I recall correctly, where it's Kotlin for their client as well as their backend. So they're writing their server logic in Kotlin as well. And I think this is going to continue more and more. So it's the one lang to rule them, one lang to find them, one lang to bring them all, and in the Kotlin bind them. So that, to me, is a real positive thing, to go from essentially having to work with 3 different languages in one project to be able to write everything all in Kotlin. It's a huge step. So what I'm here to talk about, build scripts, do not touch. It might break. Engineers seem to avoid refactoring Gradle scripts because it feels like a house of cards or dominoes. I've experienced this many times. So, the reason I think engineers are some of the reasons engineers are avoiding or tend to avoid build scripts. They build it once and leave it, or they add whatever bit they need, and you end up with these as applications become more complex, these build scripts become kind of messy and certainly error prone. But part of the reason is because feedback from errors is not live, right? There are no compile time checking. So one change, like even just adding a semicolon in a Gradle file, will put the project out of sync, and feedback on the change will only come after Gradle is synced. In large projects, this can cost a lot of developer waiting time. If you have a project that takes 4 minutes to compile, and you have written an error in one line of code, that's expensive, to then test that again. As I said earlier, there are ways to get more feedback, but even then, like output from Gradle stack traces and debug flags can be overwhelming, to even figure out which phase, in which phase an error might be coming, whether it's configure, compile, or execute. And then as apps get bigger and build scripts get more complex, they want to take the benefit of abstracting some of that logic. But again, without the compile time checks and without like resource linking or being able to navigate to usages of your variables or tasks, it becomes really that much more difficult to debug at scale. And these IDE features have become practically essential for Android development at scale, and it just hasn't been available when it comes to build scripts. And this is why the Kotlin DSL is so cool. So as I was saying, as an app grows, build logic becomes more complex, and good tooling to maintain build logic becomes more and more important, if not imperative. So as they say in the DSL blog, the Gradle DSL blog, that the static nature of Kotlin enables both compile time checking and authoring assistance from your IDE. So you get all those great things that Sam was showing us, from auto-completion to refactoring and everything in between. So some examples of how this is really cool, especially for anybody who's ever worked in a build.gradle file. Your compile time checks. So you can see an example here where I started to create a task, and this is, this foo does not exist. The syntax is incorrect, all kinds of things. In a Groovy script, the IDE would not tell you this. You'd have to run the script to figure out that this was mistyped or non-existent. And then code completion, again, something this is not available for custom classes. So this test libs Kotlin class is written by us. In fact, it's an object within our dependencies class. And if this were Groovy, it would not point us to this. It just gives us nothing. And then refactoring, a big deal. You can see I'm going to rename test libs, and it changes everywhere. Again, this is like anybody who's been working in Android for a while and had to refactor Gradle scripts, you did not have this feature at all. So what I'm going to do is attempt a demo, which might make me crazy for attempting a Gradle demo, and it comes with a bit of a bonus that in that I'm going to also, I think somebody asked the question of Sam, I'm also going to demonstrate one of the, well, certainly my favorite Kotlin linting tool called KT Lint. So let's see, everybody can see the IDE out. Okay, so I've got a library. It's actually a group of libraries that I've been refactoring for work. It's a very simple, basic utility library. So it holds like our global constants and our custom logging and some basic details. Yes, sir.
I just want to call it, the font is pretty small in there. I can't read on my screen, so I don't know how it is for other people, but if you can pull it up. There.
Sure. Let's see if we can get, there is supposed to be a presentation mode. It's not going to give us what we need. I was looking for increasing the font, but let's see.
Yeah, so you can do that if you go into your preferences and then you search for font. I put my font size to 24 point. So that's in, go preferences and then just search font. And then I think the first one will come up under like appearance. Yeah, there's a font size there, the second thing, and just do 24. That'll look awesome. Thanks.
Thank you. That give it to us. We applied. Is that any better? Doesn't look like it.
Oh, it didn't work, but maybe you should close and reopen it. I don't know. Yeah, maybe it's just Kotlin. I don't know.
Could be.
Sorry.
All right. Well, let's see. It's okay. Some of these super details in this class aren't going to be a big deal. If you can see the project tree here, it's pretty simple. This has already been mostly converted to the Kotlin DSL for build scripts. So an important feature to point out is this build source directory To create it, you actually have to manually create the build source, source main, and Kotlin folders. You can also create a Java folder. You can also create a Groovy folder, and you can store your Java or Groovy scripts in there as well. The good thing about this build source directory is that it compiles first. So there end up being a lot of advantages that are kind of outside the scope of this talk. It's more of a Gradle talk. So we'll do I'll show a couple little features here. So one of the main features that when you're starting this up is to create your dependencies .kt. But you know what? I'm going to start here. Oh, look, settings got the new fonts. That's interesting. I'm going to try that again one more time. Yeah, strange. Okay. So I'm going to do a quick refactor to show how you would approach refactoring a Groovy script to the Kotlin DSL. So first I'm going to prepare it, and I also will end up demonstrating how you would normally sort of resource search or navigate to find things that are in your build scripts. So I use Command R to find and replace single quotes, and I'm gonna, this is a double quote, you probably can't see, and I'm just gonna replace all. It's still Groovy, but Groovy's agnostic about these things. The other thing is we need to make this into like a method invocation. And I'm going to get rid of this for now to not complicate things. And then we can sync our project, and assuming we haven't accumulated, there we go. All right, so this is now ready to be Kotlinized. So it's pretty simple. We go to settings.gradle. We can use our IDE to refactor, and turning it from a Groovy Gradle to a Kotlin DSL script is as simple as adding .kts to the end of your Gradle script. Hit refactor, and that's it. Poof. Settings is now set up as a with the Gradle Kotlin Gradle DSL. So it can be as simple as that. Now I'll show you a little more complex refactor, and this is where we sort of get our double our extra bonus here. So we're going to implement KT lint, which is basically a Kotlin Linter. I have already prepared a lot of it. So I've prepared an extra feature of it, which is a Git hook. And there are a couple of files that need to be added. They're simple files. This is all easily found online. But basically, it will check for the pre-build and set a dependency on install Git hook. So each package before, when it's in the pre-build phase, will not be allowed to enter the build phase until Git hook has been run. So these are just sort of preset things, and then we'll go ahead and refactor this. So this is extraneous. We don't need that. Our biggest difference is here. Oh, it looks like all this already has double quotes, so we're good to go there. So there are a couple of important things we need to do here. We need to modify this configurations block. This is enabled because Groovy does have another good feature in that it is pretty good at basically lazy configuration. Kotlin won't let us do this, so we need to declare it in a more Kotlin way. So that is going to be by creating a variable. We'll call it KT lint. and we'll say it's by configurations dot creating. All right. We have our dependencies. Again, we have to refactor these into method invocations. And this is where we get a little bit more complex. So to show you this in full, I'm going to go ahead and rename this now so we can see where it breaks. So refactor, rename, .kts. Another feature from the DSL that we wouldn't get in Groovy is that it will actually be able to change these references because this exists in another KTS file. Do the refactor and we're good to go. Almost. Sync real quick and you can see we've got, right away it's telling us, uh-oh, there's something wrong with this. Yeah, so we need to Kotlinize this as well. And so to do that, I'll sort of do them beside each other. Kotlin just behaves slightly different in that you need to be more explicit about the accessors. So we're going to register. We need to give it a Java exec. Close it up, and then this is where we actually name the task. As we name the task down here, Groovy allows us to basically declare things in a very lazy way. So we need that Java exec in there. But what do we do with our group? Well, instead of it being like sort of, instead of it being a parameter, basically, we are going to add it here. Right. So you sort of get the idea. You can then pretty much, it's pretty close to just copy pasting these in and fixing where you need to fix. So this now becomes a method invocation and so on. So to sort of speed things up, I'm going to pop in the pre-written Kotlinized versions of these tasks. Sync this. Okay, so just to note, these were these sort of extra files we had to add in. This is a pre-commit file that is a bash script that talks to Git, basically. And in here, turns out to be a pretty important file depending on how you write tests, especially considering Kotlin gives you the ability to write very explicit test names that will be often much longer than the standard 100 lines. So we use this to set the lint for max line length and turn it off. That's just what those are. So in order for KT-lint to run the way we want it to run, we have to actually build the project. Hopefully it won't take too long. This is where I'm nervous about demoing Gradle because all right, good deal. So let's see. We're gonna go. I'm going to commit the changes that I made. I have a Git config that allows me to be less verbose with my Git, and we're running the pre-commit Git hook. And this is KT Lint checking the project. So pretty. Oh, so let's see, what are the results? It didn't let me, oh, build failed. Why? Ah, look, we have unused imports. We have all kinds of extraneous stuff in that doesn't follow the Kotlin style guide. So this second task that we created in the KT Lint, this one's called KT Lint format. We run, oops. KT Lint format. And what else did we get? Let's see, build failed. Why this time? Wildcard imports that cannot be auto-corrected. Well, can't be auto-corrected by KT Lint, but Android Studio can optimize imports for us as long as your settings are set. You have to. Sometimes I don't think they're default set to avoid wildcards, but you go into your settings for both Kotlin and Java and for code styles and your preferences, and you can set it to avoid wildcards, basically. Optimize the imports. Let's give it a second. All right. Let's try committing again. What didn't like this time? That was unaffected by me. What are we missing? Oh, right. So now we have to run format again because the other bugaboo, which is it wants everything to be, wants imports to be alphabetical. Build successful. Let's try the commit. Aha. And we got our commit message there. So there we go. Quick demo of how it all works. A good demo of, or how the Kotlin DSL for Gradle works, as well as one of my favorite new libraries. If anybody's had to do lots of PR reviews, any of those little nitpicky things like extra spaces or wildcard imports can be dealt with before a developer can even commit, which is super helpful. And yeah, this is just sort of one of the bonus joys of Kotlin for me. So that's it. Pretty simple. You can find me on Twitter. These places are meetup GDG Silicon Beach, and I'm Jerry Henny. Thank you so much.
Very much, James, and we have a few questions if you want to go to the Q&A.
For sure. Yes, that is the Millennium Falcon in the background. I like to build stuff, so an appropriate position for me to be in working on build scripts.
Yeah.
Would it be worthwhile converting all your Gradle files to Kotlin or just the new ones? That really depends. If you have a large code base, I wouldn't recommend refactoring everything. Certainly not at once. It's definitely something you need to do a little bit at a time. Build scripts are still pretty fragile. Kotlin doesn't really reduce the fragility. It just really helps with all the things you can't do for finding the reasons why your build scripts break. Will it be difficult to convert without help from the IDE? The IDE doesn't really help much with conversion. So there have been some tricky things. My colleague and I, we've been implementing the Kotlin DSL in any new applications that have been coming up recently at the company, and even then, where we're like, there's some standards, like we had, implementing SonarQube for test coverage and things like that have been more difficult to convert. But yeah, there's a growing body of information out there, and again, it's sort of that like you get into almost a Groovy / DSL brain where you have to try to think more more Kotlin in an idiomatic way to solve some of these issues. Let's see, would I recommend immediately converting to Kotlin build scripts for a new project? That is becoming my opinion. I do. I found it incredibly helpful, certainly as at the company I'm generally, if somebody has a problem with the build scripts, it's generally me that is pinged. And so I have a lot of headaches over debugging. And since conversion isn't really that straightforward, if it has a base of the Kotlin DSL, it has been pretty dreamy. There were a couple of things I forgot to demo, like some of the linking stuff, but it is certainly worthwhile. If you're going to start an app, I would recommend, basically trying to have as few languages in your app as you can. Certainly from an Android perspective.
Yeah, that's what I was going to ask, because this way, like you use Kotlin for your Android, for the Android code, and then you use Groovy for the build. Whereas if you have the same common language, I would assume that would at least save the cognitive load of switching between. So I don't know if that's as common an issue in the Kotlin in the Android world.
Yeah, I mean, I think it's one of those subtle things that as I've begun to focus more and more on developer productivity engineering, so like focusing on how to not just which tools, but how to make our tools and our tooling work together in order to save developer downtime. Like I think none of us would have gotten into would have found the joy of programming if the first time we tried to compile a code, it took 15 minutes, like it was, those first tries, those first exercises you do, it compiles right away and you see the magic right away. And as you get into the workforce and as you get into bigger and bigger companies or bigger and bigger projects, anyway, that joy sort of goes away as you're waiting for your code to build. So as now I'm noticing where those sort of micro things come into play, or if you have 150 developers and a build is costing them 1 extra minute each, then you could extrapolate that out into how many hours a year of developer time is lost. And that kind of context switching is a big part of that. And to me, language switching is a context switch. And I have also noticed, now that we've been implementing the DSL, that developers on other teams who would normally not even look at the build scripts are seeing the Kotlin and going, oh, this is readable to me. So I think that's a big benefit as well.
Yeah, definitely. I don't think we have any more questions.
Cool.
All right. So thank you very much, James.
Of course. Thank you.
That's the end of the session here.